Yeah. So last time, uh, in last class, we had generated our IOC file according to the FreeRTOS setup using CMSIS. Correct. Now we will see what are the files generated and what are the functions generated and how we can use them. Okay. And then we'll write code for our first project also. Here you can see this is a default task handler and all the attributes which we selected in our IOC file are given here. All init function like in bare metal, system clock and peripheral. Yeah, this function, osKernelInitialize. This function was not available in bare metal, but it's available in RTOS because RTOS works on operating system and every operating system have kernel for their working. So this function osKernelInitialize, what it does, this function initializes the FreeRTOS kernel. Okay, so we are using FreeRTOS. This function will initialize the FreeRTOS kernel and it will prepare all internal RTOS data structures such as task control block, list, delay, memory management, and everything to function accordingly. It simply prepares the RTOS environment so that tasks can be created safely. We will use it inside our main before any task creation, but I'll just open this function, press control and then hover your keyboard there and click it. So you can see this function is there. All the details of this function will be available here, which I have already explained to you. Now coming back. After that, just move down and you will see this osThreadNew, this function. Everyone can see this? Hello?
Yes.
Yeah. So this osThreadNew, this function is used to create new task. We will not use the word task because in FreeRTOS task is replaced with thread. So this function is used to create a new task, or you can say thread. When we generated our IOC file, CubeMX automatically generates it with required parameters like default task, entry function. These functions we already implemented while generating the IOC file in last class. So this function will generate all those required settings which we have already done. When osThreadNew function is called, it will allocate memory from the FreeRTOS heap. Remember, we have set our heap size around 4000 in IOC function. When we were generating IOC, we set our heap size around 4000 something. So this function will allocate our memory from that heap size, and after that, task control block will be created and new task will be added there. This function does not start immediately. It will only run after this function is called or scheduler is started. You can create multiple tasks by calling this function. For example, we are right now we are using only one task, that is for one LED toggling. So we have created one task with default handler and everything. But using this function, you can create many tasks. After this, the second tutorial which we will do is, in that we will create multiple tasks using this function. Then osKernelStart, this is starting the scheduler. This is most important function. Here you can see osKernelStart. So it is used to start the scheduler. This is most important function. When osKernelStart function is used, the FreeRTOS scheduler will start. So what does scheduler do? It will schedule all the tasks one by one. So it will be started only when this function osKernelStart is called. Okay. Sysstick begins generating RTOS tick. Previously we were using system tick, but we changed it with RTOS ticks in our IOC class, in our IOC generation. So this function will begin generating RTOS ticks. Context switching will become active, and from this moment the system is fully under RTOS control. So after calling this function, our system will become fully RTOS controlled. Okay. And if you need continuous execution, then we need to put this osKernelStart function inside main. But we are not doing this right now. Now here, while one. So in this while one, you can write any code, like in bare metal we were writing. You can write any code here and it will execute indefinitely. Okay. Below this, system clock configuration and everything is done. GPIO init, yeah, here, start default task. So whatever your task is, it will start here. So we have only one task now. Can you tell me what task we have chosen?
LED toggling.
LED toggling. Okay. So you will write all your code inside here for this first task, for your first task. Okay. So this 4 will make it infinite loop. OS delay. So hard delay we will not be using because hard delay is bare metal delay and it will stuck all your CPU. But OS delay is operating system delay. It will not keep all the CPU stuck. It will just give delay in this function. Your other function will be working smoothly without any CPU delay. That's why we use FreeRTOS, because here you can use OS delay. So here I am writing my code for toggling LED. So that is HAL GPIO, right? Okay. So my port is B, GPIO pin 5. I think everyone knows this because we have already used these functions in bare metal. OS delay, I'll not keep 1 because it will give 1 millisecond delay. I'll keep 500 milliseconds so that it can be visible for all of you. Now I'll just copy this code and paste here. But I will not keep it 1, I will keep it 0 so that it will toggle. Understood? Any problem till now?
No, sir.
No. Now
No, sir.
I'll build my code. So just stop this. Build my code here. Oh, 1 minute. I'll select my perspective debug. I'll go to Project Explorer. My project name is RTOS 2, so I'll just right click here. Now Control S, so my code will be saved. You can see here debug. Just press it. It will take few seconds. Okay. I forgot to plug in my controller here. Just give me 1 second. I'm connecting my controller using USB cable. Now it's connected. Okay. Now I'll be sending one video in our WhatsApp group. Just see it. Just let me know once you receive this video in our WhatsApp group. Balmiki sir?
Yeah, Chandan, we received. Yeah.
Okay. Okay, so in this video, you can see PB5, which is my blue LED. It is toggling with a delay of 500 millisecond. Everyone can see this.
Yes, sir.
That means our first LED toggling project using FreeRTOS is successful. If you have any doubt regarding this, you can ask. Everyone have got that video? Hello? Hello? Everyone got that video?
Yes, sir. Yeah, I got it.
Okay. Okay. Now, our first tutorial ends here.